This presentation explores an innovative interdisciplinary terminological framework designed to bridge the gap between disparate fields of study. By defining terms with meticulous etymological insights, practical applications, and corresponding vocations, we aim to foster dynamic growth and seamless integration across various academic disciplines. We will delve into the core of bioelectrosemantic morphogenesis, quantum lexicography, and myco-linguistic symbiosis, enriching our understanding of how these concepts can revolutionize our approach to language and technology. Bioelectrosemantic morphogenesis. Definition: the process by which biological entities utilize bioelectric signals to shape and organize linguistic structures through semantic fields. Application: applied in neuroscience for brain-machine interfaces and in language processing for creating adaptive AI systems that can understand and respond to complex human emotions. Vocations: neuro-linguistic programmers who develop advanced neural interfaces, cognitive scientists researching language acquisition, and AI researchers designing emotionally intelligent systems. Quantum lexicography. Definition: the study of dictionary compilation and lexical databases through quantum computing principles, enabling dynamic and multi-dimensional word networks. Application: real-time language translation and semantic analysis using quantum algorithms that can process multiple layers of meaning simultaneously, enhancing translation speed and accuracy. Vocations: computational linguists specializing in quantum algorithms, quantum information scientists working on language processing, and lexicographers developing quantum-enhanced lexical databases. Myco-linguistic symbiosis. Definition: the interaction between fungal networks, mycelium, and linguistic systems to explore decentralized language distribution and semantic growth. Application: developing resilient communication networks inspired by biological models, mimicking mycelial networks for decentralized, self-healing data transmission. Vocations: mycologists researching fungal communication, network engineers designing bio-inspired systems, and language model developers creating adaptive, decentralized language systems. Neuromorphic syntax engineering. Definition: designing syntactic structures for AI systems based on the architecture and functionality of the human brain's neural networks. Application: creating human-like language processing capabilities in machines, enabling more natural and intuitive human-computer interactions. Vocations: AI engineers specializing in neuromorphic computing, computational neuroscientists modeling brain function, and linguists developing syntax for AI systems. Electromagnetic phonology. Definition: the study of sound systems and phonetic variations through electromagnetic wave interactions, including frequency modulation. Application: enhancing audio compression algorithms, improving speech recognition technologies, and developing more efficient methods for wireless communication. Vocations: acoustic engineers researching sound wave properties, speech therapists using electromagnetic therapies, and signal processing specialists improving communication technologies. Cognitive onto semantics. Definition: a framework that integrates cognitive psychology, ontology, and semantics to map human thought processes through language categories. Application: building cognitive models for virtual assistants, creating adaptive educational tools, and improving the accuracy of natural language processing systems by mirroring human thought. Vocations: cognitive psychologists studying human thought processes, knowledge engineers developing ontological structures, and educators creating cognitive-based learning tools. Isotopic etymology, definition, tracing word origins and historical linguistic shifts using isotopic dating methods and comparative analysis. Application: historical linguistics research, forensic linguistics identifying language patterns, and archaeological studies uncovering ancient languages through material remains. Vocations: historical linguists studying language evolution, archaeologists uncovering ancient languages, and forensic analysts identifying linguistic patterns using isotopic data. Linguistic quantum entanglement. Definition: exploring nonlinear and simultaneous linguistic relationships inspired by quantum entanglement theory, allowing for instant connection between disparate linguistic elements. Application: advancing multilanguage processing systems, creating real-time global communication networks, and developing unbreakable codes based on quantum principles. Vocations: quantum physicists researching entanglement theory, language technologists developing advanced processing systems, and data scientists analyzing complex linguistic data. Morphosyntactic harmonization, universal standards, multilingual systems, aligning rules. This process involves aligning morphological and syntactic rules across languages to create universal linguistic standards, leading to more effective global communication protocols and enhanced multilingual education systems. Semantic gravimetrics, measuring and analyzing the weight of semantic structures and meanings in linguistic discourse using gravitational modeling analogies. This technique enhances information retrieval systems and semantic web development by prioritizing contextually significant information. Quantum morphophonemics, advanced speech, multilingual systems, quantum principles. This is the study of phoneme and morpheme interactions influenced by quantum principles such as superposition and entanglement, used in developing multilingual phonetic translation systems and advanced speech synthesis that captures nuances of human speech. Biosemic nanocircuitry. Definition: implementing biosemantic data processing in nanoscale circuits, using biological molecules for linguistic computations, blurring the lines between biology and technology. Application: advancing biocomputing systems, creating neural language processors, and developing biocompatible linguistic interfaces that can interact directly with the human brain. Vocations: bioengineers designing molecular circuits, computational linguists programming biosemantic data, and nanotechnologists building nanoscale linguistic processors. Electrolexical kinetics, the dynamic movement of lexical elements within electric and magnetic fields for real-time language transmission, enabling instantaneous communication. Applications include wireless communication protocols, neuroelectronic language interfaces, and high-speed data transfer that relies on the electromagnetic manipulation of lexical data. Vocations involve electrical engineers designing electromagnetic systems, lexicographers encoding language data, and communication specialists optimizing wireless transmission protocols. Symbiogenetic philology. The coevolution of languages through symbiotic relationships between diverse cultures and species, highlighting the interconnectedness of linguistic development. Applications cover cultural linguistic studies, preservation of endangered languages, and understanding how linguistic diversity arises through cultural exchange and biological coevolution. Vocations include philologists researching language evolution, anthropologists studying cultural exchange, and cultural historians preserving endangered languages. Morphogenetic linguistic fields. Linguistic structures generated through morphogenetic fields that influence semantic growth and syntactic stability, providing a framework for understanding language development. Applications involve language evolution modeling, AI grammar training, and creating artificial languages that evolve organically based on inherent morphogenetic principles. Vocations encompass morphologists studying language structures, evolutionary linguists researching language development, and AI trainers developing adaptive grammar models. Etymophysical dynamics. Definition: the interplay between the physical properties of sound waves and the historical evolution of word meanings, linking the physical world to language evolution. Application: acoustic etymology analysis, phonetic pattern recognition, and understanding how sound shapes meaning over time through physical interactions. Vocations: etymologists researching word origins, acoustic engineers analyzing sound properties, and linguistic historians tracing language evolution through sound. Neural pragmasemantics. Definition: the neural basis for pragmatic and semantic processing in human cognition, connecting brain function to language understanding and use. Application: cognitive behavioral therapies, brain-based language learning tools, and understanding how the brain processes context, intention, and meaning in language. Vocations: neurologists studying brain function, psycholinguists researching cognitive processes, and educational technologists developing brain-based learning tools. Linguistic astrogeodynamics. Definition: the study of language systems influenced by geodynamic and astronomical factors, exploring how Earth and space impact linguistic development. Application: designing extraterrestrial communication systems, linguistic signal analysis in space exploration, and understanding how geographical factors shape language diversity. Vocations: astrophysicists researching space phenomena, geolinguists studying geographical influences, and space communications engineers developing interstellar protocols. Biophotonic lexisynthesis. The generation and transmission of lexical data using biophotonic signals within living organisms, exploring a new frontier in biological communication. Application: biolinguistic implants, organic data networks, and creating biological interfaces that use light to transmit and process linguistic information within living systems. Vocations: biophotonics researchers studying light phenomena, lexicologists encoding language data, and medical technologists developing biophotonic implants. Recursive ontoaxiomatics, knowledge graphs, automated reasoning, ontological axioms. This involves a hierarchical system of ontological axioms applied recursively to language structures, facilitating automated reasoning systems and building comprehensive linguistic knowledge graphs. Bioacoustic phonogenomics, bioacoustic systems, speech disorders, genetic influence. The study of genetic influence on phonetic variation through bioacoustic signals in living organisms is essential for understanding genetic speech disorder research and creating bioacoustic communication systems. Quantum linguistic cryptography. Definition: securing linguistic data transmission through quantum encryption based on linguistic structures, providing unbreakable security for communication. Application: quantum secured multilingual communication platforms, ensuring that sensitive linguistic data remains protected from eavesdropping and interception. Vocations: cryptographers developing quantum encryption methods, quantum communication engineers building secure platforms, and linguists encoding language structures. Electrosemantic resonance. Definition: semantic alignment through resonant electromagnetic fields for optimized linguistic transmission, enhancing the clarity and fidelity of communication. Application: high-fidelity language transmission in digital networks, ensuring that meaning is accurately conveyed and received across communication channels. Vocations: telecommunication engineers optimizing digital networks, semantic analysts ensuring data clarity, and AI developers creating resonant language systems. Neurolexical synaptics. Definition: the synaptic interactions facilitating lexical retrieval and language processing in the brain, enhancing our understanding of cognitive function. Application: brain-machine interfaces, cognitive language training programs, and improving language abilities through targeted neural stimulation. Vocations: neuroscientists studying synaptic interactions, computational linguists modeling brain processes, and AI language designers creating adaptive language systems. Linguistic morphochemical dynamics. Definition: the chemical basis of morphological language development and structural variations, exploring the building blocks of language. Application: drug development for language-related cognitive disorders, improving language abilities through chemical interventions and understanding the biological basis of language. Vocations: chemists studying molecular structures, morphologists researching language structures, and neuropharmacologists developing cognitive-enhancing drugs. Cognitive semiotic networks. Definition: networks of cognitive processes that interpret and generate semiotic systems, linking thought and symbol systems. Application: AI-generated sign languages, multilingual cognitive interfaces, and creating communication systems that adapt to human thought processes. Vocations: cognitive scientists studying thought processes, semioticians researching symbol systems, and AI developers creating adaptive interfaces. Biolinguistic Phylogenetics. Definition: tracing linguistic evolution through biological and genetic phylogenetic methods, mapping the history of language. Application: evolutionary linguistics, species communication studies, and understanding how languages evolve through genetic and biological influences. Vocations: biologists studying genetic influences, phylogeneticists mapping evolutionary trees, and historical linguists tracing language development. Magnetophonetic dynamics. The impact of magnetic fields on phonetic articulation and perception, exploring new avenues for speech therapy. Magnetic resonance-based speech therapy devices, improving speech abilities through targeted magnetic stimulation, and understanding the neural basis of articulation. Speech therapists using magnetic devices, magnetic field researchers studying neural impacts, and acoustic engineers designing therapeutic tools. Gravitosemantic fields. The influence of gravitational forces on semantic cognition and language processing, opening new frontiers in language understanding. Space-based communication systems, zero-gravity linguistic studies, and understanding how gravity impacts language in extreme environments. Astrophysicists researching gravitational impacts, cognitive linguists studying brain processes, and space communication engineers developing interstellar protocols. Recursive linguistic morphosynthesis, automated generation, pattern recognition, morphological elements. This involves the iterative synthesis of morphological elements through recursive linguistic algorithms, enabling sophisticated morphological pattern recognition in automated language generation systems. Quantum etymosemantics, multilingual research, real-time analysis, quantum state. Quantum etymosemantics is the study of word origins and meaning variations through quantum state analysis, integrating historical linguistics with quantum theory for innovative language modeling. Bioelectromagnetic syntax networks. Definition: neural networks that process and transmit syntactic structures through bioelectromagnetic signals, enhancing neural language decoding and communication. Application: neural language decoding systems, brain-computer interfaces for real-time translation, and understanding the biological basis of syntactic processing. Vocations: neuroscientists studying brain function, syntax theorists modeling language structure, and biomedical engineers developing neural interfaces. Morpho-symbiotic linguistics. Definition: the interaction and co-evolution of morphological structures in language through symbiotic relationships between species and cultures, fostering linguistic diversity. Application: studying language change in multilingual societies, developing adaptive linguistic systems, and understanding how cultural exchange shapes language. Vocations: anthropologists studying cultural influences, morphologists researching language structures, and sociolinguists analyzing language change. Genolinguistic coding. Definition: encoding linguistic information in genetic sequences to explore the genetic basis of language abilities, providing insights into language disorders. Application: research in language acquisition disorders, genetic markers of multilingual proficiency, and understanding the genetic influences on language learning. Vocations: geneticists studying DNA sequences, language acquisition specialists researching learning disorders, and bioinformaticians analyzing genetic data. Definition: the influence of electrodynamic forces on phonetic articulation and semantic interpretation in speech, optimizing voice recognition technology. Application: enhancing voice recognition technologies, improving auditory processing in noisy environments, and understanding how electromagnetic fields affect speech perception. Vocations: acoustic engineers optimizing voice systems, phonologists researching speech sounds, and AI developers creating voice recognition algorithms. Quantum lexemic entanglement. Definition: entangling lexemes across languages through quantum superposition, enabling simultaneous multilingual interpretation for enhanced communication. Application: multilingual quantum computing interfaces, real-time cross-lingual data processing, and instant translation across diverse languages. Vocations: quantum information scientists studying quantum phenomena, lexicographers encoding language units, and translation technologists developing multilingual interfaces. Biochemical linguistic resonance. Definition: the resonance of biochemical signals in the brain that modulate linguistic processing and memory retention, aiding cognitive enhancement. Application: cognitive enhancement therapies, language retention techniques, and understanding how biochemical signals affect language learning and recall. Vocations: biochemists studying brain signals, cognitive psychologists researching memory processes, and educational technologists developing retention techniques. Definition: the genomic basis of phonotactic constraints in human neural networks, providing genetic insights into speech patterns. Application: developing personalized speech therapy programs, phonological research, and understanding the genetic influences on allowable sound sequences in languages. Vocations: neurolinguists studying brain processes, genetic researchers analyzing DNA sequences, and speech therapists creating personalized programs. Linguistic quantum metamaterials. Definition: artificial materials engineered to manipulate linguistic signal propagation through quantum effects, enhancing language transmission. Application: advanced language transmission systems, noise-canceling communication devices, and improving signal clarity through material engineering. Vocations: materials scientists engineering metamaterials, quantum engineers studying quantum effects, and communication specialists optimizing signal transmission. Recursive semantic taxonometrics, search engines, language databases, taxonomic structures. This includes recursive classification and measurement of semantic fields using taxonomic structures, integrating etymology, syntax, and pragmatics for powerful language analysis. Bioelectrolexical fusion, linguistic therapies, language implants, bioelectric signals. The fusion of bioelectric signals and lexical units to create adaptive language processing systems enables neural language implants and enhances cognitive linguistic therapies. Quantum syntax resonance. Definition: The application of quantum resonance to syntactic structures enables parallel processing of complex grammatical frameworks and enhances computational linguistics. Application: real-time syntax correction, multilingual sentence generation in quantum computing systems, and high-speed linguistic analysis. Vocations: quantum programmers developing syntax algorithms, syntacticians modeling sentence structures, and computational linguists creating quantum tools. Chemosemantic encoding. Definition: encoding semantic information through chemical structures facilitates biochemical language transfer and storage, pushing the boundaries of data storage. Application: molecular communication systems, biochemical data storage, and advanced interfaces that rely on chemical interactions to transmit information. Vocations: chemists designing molecular structures, semanticists encoding information, and data storage engineers developing biochemical systems. Linguistic entropic dynamics. Definition: the study of entropy in linguistic systems measures disorder and predictability, providing insights into language evolution and usage. Application: language evolution modeling, optimizing information transmission, and understanding how language structures adapt to maximize clarity. Vocations: information theorists studying communication, evolutionary linguists tracing language development, and network analysts optimizing transmission. Neuromorphic pragmatic networks. Definition: neural-inspired networks designed for processing pragmatic language elements revolutionize context understanding in AI systems. Application: context-aware AI systems, advanced virtual assistants, and more intuitive interfaces that respond effectively to human intention. Vocations: AI developers creating intelligent systems, pragmatists modeling language context, and computational neuroscientists simulating brain processes. Isotoposemiotic synthesis. Definition: synthesizing semiotic systems using isotopic labeling traces, meaning formation and evolution, aiding diachronic studies. Application: language forensics, diachronic linguistic studies, and understanding how meanings evolve over time through isotopic analysis. Vocations: semiotic analysts interpreting symbol systems, forensic linguists analyzing linguistic data, and isotope researchers studying material composition. Morphogenetic linguistic algorithms. Definition: morphogenetic algorithms dynamically generate and evolve linguistic structures, enhancing AI language models with organic-like development. Application: AI language evolution models, automated lexicon expansion tools, and AI systems that organically adapt to linguistic changes. Vocations: algorithm developers creating dynamic models, morphologists studying language structures, and AI linguistics researchers exploring adaptive systems. Electrophonetic waveforms. Definition: modeling phonetic variations through electromagnetic waveforms enables high-fidelity auditory reproduction in advanced voice systems. Application: advanced voice synthesis, secure voice transmission systems, and improved communication clarity through electromagnetic engineering. Vocations: acoustic engineers modeling sound, phonologists studying speech sounds, and telecommunications specialists optimizing signal transmission. Gravitolexical dynamics. Definition: the interaction between gravitational forces and lexical formation explores how language structures change under extreme conditions. Application: linguistic research in microgravity, space communication protocols, and adapting language to extraterrestrial environments for future exploration. Vocations: astrophysicists studying gravitational forces, lexicographers modeling word formation, and space communication engineers developing interstellar systems. Recursive linguistic epistemologies, curation systems, AI language models, knowledge systems. This framework of knowledge integrates historical, semantic, and pragmatic elements for linguistic knowledge synthesis and self-learning in AI language models. Key takeaways: interdisciplinary integration. This framework facilitates collaboration across diverse fields, fostering innovation and novel approaches to language and technology. Enhanced understanding. By exploring the connections between language science and technology, we gain a deeper insight into the nature of communication and cognition. Future innovations. These concepts pave the way for advancements in AI, communication systems, and our understanding of the human brain and language itself. Future research directions: quantum linguistics. Exploring the quantum properties of language could lead to breakthroughs in artificial intelligence and communication technology. Neuro-linguistic interfaces. Developing direct brain-language interfaces could revolutionize communication and cognitive enhancement. Biosemantic systems. Integrating biological and linguistic systems could lead to new forms of data storage and processing. Practical applications: artificial intelligence development. These concepts can be applied to create more intelligent and context-aware AI systems capable of understanding and generating human-like language. Communication technology. Innovative approaches can lead to advanced communication systems that are faster, more secure, and better adapted to human needs. Cognitive enhancement. Understanding the neural and biochemical basis of language can lead to new therapies for cognitive disorders and enhancement techniques. Next steps: collaboration, research, implementation. We need to foster collaboration across disciplines, continue conducting rigorous research, and implement these innovative concepts in real-world applications to realize their full potential. Call to action: join the conversation. Share your ideas, insights, and expertise to help advance this interdisciplinary framework. Support research. Invest in research that explores the connections between language, science, and technology. Embrace innovation. Be open to new ideas and approaches that can revolutionize our understanding of language and communication. Thank you. Thank you for your attention and engagement in this exploration of interdisciplinary terminologies and frameworks. Your contributions and interest are vital to the continued development of these concepts. Q&A. We now welcome your questions, comments, and insights. This is an opportunity to delve deeper into the topics discussed and further clarify any uncertainties. the pursuit of information. For further inquiries, collaborations, or discussions, please reach out to us in the comment section below. We are open to exploring new partnerships and research opportunities. Conclusion: this interdisciplinary terminological framework represents a significant step toward bridging disparate fields of study and fostering innovation in language, science, and technology. Continued collaboration and research will be crucial in unlocking the full potential of these concepts and shaping the future of communication and